Again, thank you for having me with you. My talk today, The Magnificent Obsession, Unveiling the Mystery of the Three Monads. The magnificent obsession, really in a nutshell, is to discover what is the structure of the cosmos, of nature, and of consciousness. And secondly, how do we get back to the source from whence we came? So I've listed this here as number one, how does the one become many? That in fact is the greatest philosophical question. And particularly for esoterists and theosophists, actually everyone, how do each of the many, you and I, return back unto the one? And Heraclitus gives a clue, the way up and the way down are one and the same. If we can figure out how the one becomes many, we have what I would call Ariadne's golden thread down into this labyrinthian world that we live in. And then how we return back to the source, we have the thread, because once we understand how we got here and how the structure works, we can follow that thread or that structure back. H.P. Blavatsky maintained that Plato is the world's interpreter, and the ideas of both Pythagoras and Plato are identical with ours, with Theosophy. Key to Theosophy, page 96. However, very few have penetrated into the deepest esoteric mysteries of the Pythagorean Plato. We will look at Plato's hints, the empirical evidence, and finally, the mystery of the three monads for clues to the proportional golden symmetry underlying the cosmos, nature, and man. In the process, we will carefully tread the path up to the very threshold of illumination, seeking reunion with the one, or samadhi. It's for that reason that I maintain that this may be one of the most esoteric talks I've ever given. In the right-hand side of the screen, you see the grand unification of the sciences, arts, and consciousness, rediscovering the Pythagorean Plato's golden mean number system. That's a book I mentioned that I've done together with the three physicists. Okay, background. Of course, this is one of the shamanic paintings that I collect, doing that for several years. So I make no secret of the fact that I work very closely with the shamans, curanderos female, particularly curanderos in South America, in Peru, in the rainforest, and have done considerable work trying to understand from the perspective of non-ordinary states of consciousness, mystical experience, what in fact is going on. And often there is a communion with, for me, the big cat. Very typical. But we see this in all cultures. We see it with Shiva up in the upper left here, on a tiger rug, sometimes a leopard rug in Africa. This is from King Tut's tomb. That's a priest with the pelt of a leopard. Here we see Narasimha, the fourth incarnation of Vishnu, the lion man. This is from the Women's Mysteries in Pompeii, which was preserved, and you see Dionysus riding on the back of a leopard. This is all typical, and it's for a very good reason. The Huichol Indians in Mexico, after they've done their peyote experiences, they will come out and they'll do these. In the bottom center, you'll see these beautiful jaguar heads with the little colored beads. And so you get sacred geometry, and then you get nature as well, kind of combined with the big cat. One of my cats, Maya, no longer with us, she thought she was a big cat, so I had to take a shot of her too. So I take Plato's admonition that learning is remembrance very, very seriously. And so drinking from the well of Mamur and the Odinic mysteries, the well of remembrance, is a very realistic, very real thing. most recently, when I was in the rainforest just a couple months back, I had another incredible experience with a dragonfly. That's happened previously, but this time I was looking for a dragonfly to lock eyes with, and I won't talk about it now, but I can tell you I learned part of the secret of the sixth limb of yoga, dharana, one-pointed concentration, from the dragonfly. Most significantly, and this is extremely important, it is the golden proportional symmetry that was revealed in the ancient initiations, passed down by the Atlantean adepts. And it is within this initiatory tradition of the mysteries that, now that's a paraphrase from HPB, but the rest is a direct quote. All the rules of proportion are those taught anciently at initiations, and one should acquaint oneself with the truly divine art and understand the deep esoteric significance hidden in every rule and law of proportion. Volume 1, page 208. The italics are HPBs. So in the mystery schools, what was happening, they were entering into non-ordinary states of consciousness so that they could resonate with higher beings and with these higher levels of awareness. And it was the rules of proportion, particularly golden proportion, that was critical, but was forbidden to be revealed to the uninitiate on penalty of death. Now in 2005, in the rainforest, I had a major epiphany experience in which I was shown much of what I already knew because I'd been studying the golden section for 30, 40 years. But I was shown both outside the body, inside the body, connecting with everything, how it works in detail and across the board. I remained awake for 19 consecutive days, actually 23, but 2 of those days towards the end, I lost consciousness or blacked out or went to sleep for maybe about an hour twice. But for 19 days straight, I was fully alert, each day reconnecting with the eternal now. And then 6 months later, the book was written, The Golden Section, much of it done in Glastonbury with John Martineau, and published in 2006. We've already talked about it, and Tim did such a nice introduction, I won't say more. This year in 2021, there wasn't so much of an epiphany. Well, there was, but not as I would have expected. But let me go back to 2005 here, actually. I would also take plants. This is a very small plant, and I would number, you see like number 2, etc. on this. And I was studying, trying to figure out what it is about a 5-petaled flower, which most flowers are, by the way, which immediately gives you golden ratios, where the 137.5 degrees genetic angle, the divergence angle, is, which rules phyllotaxis, which rules leaf arrangement. And I had kind of a vision of taking the compass and nesting these pentagrams, and I got to a point, well, before I say this, I need to tell you, the buds, the flowers, the petals do not come up in sequence. The first thing I noticed when I examined the flowers was they come up, they alternate. Now, if you have a 360-degree circle and you have a pentagon and you have 2/5 of the pentagon, that's going to be 144 degrees from the center. But what I realized is this divergence angle occurs slightly off center. This is the Archimedian leverage right now, and you can see where that 137.5 degrees is built in. This time, 2021, this is the top of the Maloka. Normally, we simply are isolated individuals working on our own issues, but then we gather together for ceremonial experiences. And the one night I looked up, I saw the top of the Maloka is the universe, and I had been working on the new book for 1.5 years. And I realized, oh my God, it is so simple. because I was able to start putting together the dots in the ceiling of the Maloka that I had been taught as I worked for that. I just labored for a year and a half on that book. And it became so simple. And it really boils down to the primordial scission, which the ancient Egyptians called the very beginning, and the Great Pyramid. In fact, the pyramids in general, the temples, of which Badawi found more than 50 temples, are based on Fibonacci numbers, which means they're golden ratios. And that's the key. It's the golden cut, but more on that. The one piece in the book that I found is probably the most important, or one of the most important pieces, was an observation by Alexei Stakov. In Einstein's relativity theory, they used Lobachevsky's classical hyperbolic geometry. The problem is it's non-recursive. It doesn't repeat. You don't get self-similarity running throughout the universe with this because it's based on Euler's constant. However, Bodner's, who's a Russian, Bodner's hyperbolic geometry and hyperbolic Fibonacci and Lucas functions are based on the golden section, which satisfy what Dirac called a principle of mathematical beauty. And this is one of the most beautiful of mathematical constants, is the golden ratio, as we all know. Now, as Alexei Stakov pointed out, these functions are recursive. They result in self-similarity at all scales. That's why the same patterns repeat, whether you're talking about a galaxy, super galaxy, universe itself, solar system, Earth, human being, organs, cells, structure of the human body, quarks, the whole works. In this, as he says, quote, "This provides a simple explanation of why Fibonacci spirals appear on the surface of phyllotaxis objects, objects that have not only leaf arrangement, but things like sunflowers and pine cones, etc. If nature actually operates according to the model suggested by Bodner, then it's not unreasonable to suggest that nature acts as a great mathematician, employing recursive hyperbolic Fibonacci and Lucas functions throughout its creative efforts." Now, Bodner's book is now in English. It's been in Russian, but in 2015, they did publish it, Golden Section in Non-Euclidean Geometry in Science and Art. And the quote was from Stakov. I assisted him in this book with Aronson, the Golden Non-Euclidean. I hear a question? Or no. So upon thoughtful consideration of a staggering body of anomalous evidence, it appears that a profound golden mean number system may underlie the cosmos, nature, and consciousness. This is the pervasive and puzzling presence of the golden ratio throughout physics, chemistry, biology, and cosmology, often veiled in Fibonacci and Lucas numbers, which, as we will see, any two adjacent Fibonacci numbers or two adjacent Lucas numbers, when you create a ratio of them, they approximate the golden ratio. And the higher the numbers go, the closer they get to the golden ratio in the limit. This ontological superstructure, okay, ontology, what exists, the structure of the universe, consciousness, and nature itself, this ontological superstructure was known to Plato and the Pythagoreans and was called the one and the indefinite dyad. But there was always a mystery as to what the greater and lesser of the indefinite dyad were. I'm going to tell you right off, straight out, we figured it out. It all fits with all of Plato's work. The greater is the golden ratio. The larger version of, there's really two versions, and each are reciprocals of each other. And we'll see that in a second, but I just want to point this out now. So the greater is basically 1.618, keeps going to infinity. It's an incommensurable. 1.6180339, the lesser is exactly the same number without the one. It's 0.6180339. These two together with unity or the one are what make up the one and the indefinite dyad. Plato and the Pythagoreans. It was Philolaus who maintained and all things that can be known contain number. Without this, nothing can be thought or known. Plato puts out a very interesting statement in the Timaeus, 31b to 32a. He says, two things cannot be rightly put together without a third. There must be some bond of union between them. And the fairest bond is that which makes the most complete fusion of itself in the things which it combines, and proportion, analogia, is best adapted to effect such a union. Now, what he's really talking about here is what's called continuous geometric proportion. But we'll see this in a second. Also in the Timaeus, it begins with the statement 1, 2, 3, but where is the fourth, my dear Timaeus? There were 4 guests there yesterday, but now today, one of them is missing. But this is one of Plato's cryptic ways of hinting that something is missing in the dialogue. We do know from Speusippus, his nephew, from some of the fragments of on-Pythagoreanism that still exist, and the Timaeus itself, that 1 was symbolic of the equilateral triangle because all the sides are equal. The 2 referred to the root 2, half of a square, which would build up the cube, for example, and square root of 3, which is the bisection of the equilateral triangle, where the base is 1 and the side is 2, but this is square root of 3. So 1, 2, 3, but where the heck is the fourth, my dear Timaeus? Something's missing. What's missing is a description of how to construct the dodecahedron. That was forbidden. That was what was revealed in the mystery schools. To give away the construction of the dodecahedron, you would have to reveal the golden section, and that was absolutely forbidden. 3 of the Platonic solids, fire, air, and water, or the tetrahedron, octahedron, and icosahedron, all have equilateral triangles and therefore root 3 as their kind of guiding ratio, whereas the cube again is root 2. But here we have pentagonal sides which require the golden ratio, and it's conspicuously absent in Plato. Then Plato gives us this big hint. These then we assume to be, I've got to move this, the original elements of fire and other bodies, but the principles which are prior to these, deity only knows, and those of men who's a friend of deity. Anyone who can point out a more beautiful form than ours for the construction of these bodies shall carry off the palm, not as an enemy, but as a friend. He who disproves what we are saying and shows that we are mistaken may claim a friendly victory. Well, this is kind of stuff coming up from the past. Some of you have seen my work before, so I'm showing you all of this now. So here was a construction that I did fairly early on, and I'll explain it in 1 second. And I call this the golden chalice of Orion because it's kind of like Orion, as you see here, and this would be the belt of Orion. This is a golden rectangle, if you see where I'm taking my cursor and moving it around. However, I extend the side, so the length of this side is what we call the greater golden ratio, 1.6180339. The distance from here to here would be 1. The distance from this point here to this point here would be the lesser, would be 0.6180339. When you create a square with the sides of the greater, which later we're going to learn is representative of beauty, you'll find that we can construct this golden chalice. And I won't go through the process, that's not so important here, but the dimensions of it are. Because what we find is that you can immediately derive through these diagonals square root of 2 and square root of 3 simply by using big phi and little baby phi, or the greater and the lesser. And eventually we're going to realize this represents truth. So beauty and truth are going to be incorporated through the golden ratio, its greater version and its lesser version. This, by the way, is the height of the Great Pyramid, square root of the greater, or phi. And this, when you connect up this point out here, you'll find that you have, which is 1, the base of the pyramid being 1, you'll have the apothem, the slope here is exactly the greater. So the Great Pyramid is, in fact, it's a monument to the golden ratio. It's just incredible. So here I am with Keith Critchlow, John Michel. They've been extremely important in figuring this out. And let me just remind you, when Plato said, you need a third factor to bond the two. You can look at those things horizontally or vertically. Think of Hermes, as above, so below, and as below, so above. Those two, the above and the below, the macrocosm and microcosm, have to be joined in the middle by a geometric mean that bonds them together. And that's part of the key, and that's where the golden mean comes in. So Critchlow in Time Stands Still says these 3 special ratios, square root of 3, square root of 2, and the golden mean in both its versions are directly related, well, we've already seen this, to the triangle, the square, and the pentagon. They recur consistently throughout the proportioning of the sacred buildings of humanity. So that's what's happened. It's been realized what these things are and their value and how they work in the universe, and the ancients then translated them into their structures. And then Michel, in The Dimensions of Paradise, maintains that man, temple, man the microcosm, temple the mesocosm, and the macrocosm, the cosmos itself, were seen to be identical. And on this understanding, the entire philosophy and science of the ancient world was founded. That's from his Dimensions of Paradise. Michel and I became very close. I used to, if I didn't stay with Baker, I would stay with John Michel in London when I came into London. He did love the Golden Section book. He wrote this little poem for me, a book I greatly value. It's the pride of my collection, is Mr. Olsen's recent work upon the Golden Section. It's something that could change the world if they could understand it. Well, if they could understand it, I'm certain the authorities would long ago have banned it. The secret it exposes is a key to life's creation. I can't explain it in a line, so here's an illustration. So he did a wonderful geometric drawing showing the golden ratio, etc. So there are a family of anomalies, and we spell these out in a grand unification, and the golden ratio as abductive inference. So creative hypothesis formation, not deduction, not induction, but this is creative hypothesis formation. When you study these anomalies, you automatically infer the best explanation is the golden ratio. And it is how the one becomes many. Now, Lucian Hardy is a genius. I interviewed him in Tucson, Arizona back in 2018 at the Science of Consciousness conference. He did not even then realize what he had found years before. But here's an important statement that he makes. In the end, we are driven to search for what we hope will turn out to be the correct ontology, structure of the world. After all, it is the desire to understand what reality is like that burns deepest in the soul of any true physicist. Now, Penrose and Hameroff, Sir Roger Penrose, who last year won the Nobel Prize for black holes, and Hameroff together have a theory of consciousness. In my mind, it's the closest that we've got to being accurate. They first, and it's the orchestrated objective reduction, it's called. They first provocatively suggested that consciousness emerges through the quantum mechanics of microtubules. Now, microtubules are composed of 13 protofilaments exhibiting an 8x5 phyllotaxis. So 13 filaments, 8 spiraling one way, 5 spiraling the other, like many pine cones, in fact. And those are an 8x5, that's going to be a golden ratio approximation. 13 is to 8, that's a golden ratio approximation. And clathrons located at the tips of microtubules, as we're going to see an image in what's called the synaptic cleft, are truncated icosahedra. I'll show you an image later. So this becomes, truncation is cutting. You cut the corners off an icosahedron to get the truncated icosahedra. It's your football, or what we would call a soccer ball. A buzz with golden ratios. And DNA, in both its decagonal, 10-fold structure and its Fibonacci-guided nucleotide organization, exhibit a golden ratio, or what we call phi. Phi is another name for the golden ratio. Phi I use, and this is the uppercase phi for the Greek letter. And I use that typically to represent the greater, which we're going to see is beauty, and the lowercase letter, or the reciprocal of this, 1 over phi, or little baby phi, is the lesser. But we get this golden ratio resonance coming out of these microtubules. In the end, what we're going to find is we're tuning forks. In fact, everything is resonance. Everything is vibratory. Everything is resonance. Everything is identification. And as we progress upon the path, and the path, yes, Krishnamurti is probably right. The path is pathless. We are the path. On the other hand, where there are all kinds of clues and methods and techniques and things to build into that path, and it's all resonance that's going on. And so we resonate with higher states of consciousness. Siddhartha sits under the bo tree, and he goes into quantum coherence, lockstep, much like superfluidity and superconductivity. And we're going to see where Lucian Hardy steps into the picture here in a moment. So here is our two anomalies, and they're both by Sir Roger Penrose. He raised the question, why do Fibonacci numbers appear in microtubules? 13, 8, 5. Well, 13 is to 8, golden ratio approximation. Same with 8 is to 5. Second Penrose anomaly, quantum reduction. We're going to see these later, so I'm just kind of introducing them now. And here's the synapse. Here are the microtubules. Here are these little clathrons. Here's what the microtubules looked like. Here's one here. But the second anomaly is extremely important, is just as important. Quantum reduction, the wave collapse. When a wave becomes a particle, whether it's the Copenhagen theory of our consciousness observing collapses it into a particle, or whether there's objective reduction coming from the future, or what now some of us, me included, are thinking it's both. That it's, when things are non-local, that means they're eternal. They're there forever. They're always there. In some deep, incredible sense. Yes, it means immediate connection, but there's non-locality, not just in space, in time as well. It's a great mystery, but they're now seeing things. This is probably going to help answer issues about precognition, seeing the future before it happens. But that's a whole nother, I won't go there now. But quantum reduction is a non-local process. Well, when do we get non-locality? It's when you have entanglement. And that's where Lucian Hardy will come in. But one of my professors at Birkbeck made the most important point. The essential features of quantum interconnectedness are that the whole universe is in some way enfolded in everything, and that each thing is enfolded in the whole. That means the whole universe is enfolded into the planet Earth, is enfolded into Tim Wyatt, Gary Kidgel, every single person watching, every human being, every dog, every cat, every plant, every blade of grass, every cell, not just neurons, everything. And it's not just mammals and humans, etc. Everything has the entire universe in miniature. We are the universe in miniature. That's why we can go into these samadhi states, or into these states of consciousness where we identify with all of the Earth, solar system, galaxy perhaps, potentially in real samadhi, the entire universe. So, Scientific American, are you a hologram? This is an old magazine. Now it says quantum physics says the entire universe might be. Well, that's not a might be anymore. And the black holes are central to the whole question, and it's fractal. So if you take a portion of this image right here and blow it up, you're going to see a similar, not identical. People really get mistaken on this. It's self-similarity top to bottom. That's what fractals are. They're fractures, maintaining the information of the whole, but with some slight loss of resolution, but also slight changes as well. Now, David Bohm called this a holo movement. And the holo movement, in it, the universe enfolds into everything, beginning with what the ancient Egyptians referred to as the primordial scission, scissors, cut, the first cut, the golden section. The one, now doesn't do it in the middle. If it did it in the middle, it would be static. I mean, it'd still be important, but to get proportion, there's only one way to do it. Only one, well, two. You could cut it on one side or the other. However, the way you cut it, there's only one possible way. It's a golden cut. So you divide it into two parts in which all are bound together by continuous geometric proportion. The whole will be to the longer as the longer is to the shorter. Now, what's interesting is we have to begin with one. So we have the source. Now, the source is going to do this. But I'm going to suggest from the outset that the source of the one itself remains pure and pristine. But then magnitude emerges in the sense of a one that gets cut. Now, when you cut one, the pieces are going to be smaller than one, obviously. And so the longer segment is going to be 1 over phi, 1 over the greater, which is our little baby phi, the lesser, as I was pointing out before. 0.6180339, and then the lesser squared will be the smaller segment. Remember, if you take 1/2 and you square it, it doesn't grow bigger, it grows smaller. You get 1/4. So when you square a fraction like that, it'll continually fractalize. When you ask yourself the question, what's the relationship of the whole line to the longer segment? It's different. The longer segment is now going to be represented by 1. That means the whole line takes on the value of big phi, the greater, 1.6180339, and the shorter segment now is going to be the lesser, 0.618. Again, notice how by simply cutting 1 off of this whole line, you get the lesser. These are going to be the two. This will be the greater, this will be the lesser, and now you have unity. But notice this one right here is a little bit different than the original whole line, which represented the source. Now the source in some deep sense is being represented by phi. Let me go back because this was covering my bottom image. So we get, here's your one and your indefinite dyad, the greater and the lesser emerging out of this. Plato in the Republic says, take a line, cut it unevenly. Again, I explained to you why you wouldn't cut it evenly. Now you could cut it up here or you could cut it down here, but it's how you cut it in the golden cut, which is the only way to do this. So you have the whole is to the longer segment as the longer segment is to the shorter. So we're going to see this over here. So the whole line is to the longer in the same relation as the longest to the shorter. By the way, we could make fractions of this. We could make this the longer divided, the whole divided by the longer equals, this could become an equal sign, equals the longer segment divided by the shorter segment. And so the two inner segments in the divided line are going to be represented by 1. They collapse. So here you have it. So phi greater is to 1 as 1 is to the lesser. And because these are equivalent, you basically have your 1 and your greater and your lesser, the 1 in the indefinite dyad. So here it is. This was the big question to start with. What is the greater and the lesser? Well, they're going to be golden ratio, greater version, which is we're going to call beauty in a second, and the lesser, which is going to be the smaller version of the golden ratio, 0.618. Now, what Plato has done in the Republic, and I didn't enter this in, I took it out, there's what's called stichometry. The ancients wrote their works on scrolls. And there's a way of dividing up the scroll. So they're not pages in a book. But what Plato did masterfully, I used to think it was the divided line that exists right at the golden cut. It's actually the Sun Simile. Because what Plato does is he takes three similes, the sun, the divided line, and the cave. And he beginning with the one, he does the cut here, comparing the good to the sun. And so he calls this the Sun Simile. In the scroll, if you go into 0.618 or 61.8% of the scroll, this is where the Sun Simile occurs. He does the golden cut there. He embeds it. He would have lost his life if he had done this openly, but he embedded it there for us to find. Then in the divided line, you cut them in the same ratios. You cut the upper line in a golden cut, the lower line in a golden cut, so you get 4 portions. Notice that there's what's called the lambda. It's like an upside down V, 1, 2, 4, 8, 1, 3, 9, 27. Plato has put one arm of the lambda in here by dividing, going 1, 2, 4, 8. Each of these numbers is the geometric mean between the two side numbers. 1 times 4 is 4, square root of 4 is 2. 2 times 8 is 16, square root of 16 is 4. That's what's going on with the golden section, even more pristinely, but he's hinting at it to the reader. So the cave then gets divided into 8 segments. So I won't take time here because time will be of the essence for us in this presentation. We also know that the golden ratio, we'll take the greater version here, is the simplest continued fraction. So when we do all the substitution here, we ultimately find that the greater is equal to 1 plus 1 over 1 plus 1 over 1 plus 1, all the way to infinity. In other words, it's endless, it's infinite. But notice it's the number 1 that's involved. It's also the simplest nested radical. Again, when you do substitutions of equivalences, you find that the greater is equal to the square root of 1 plus square root of 1 plus square root of 1 on to infinity. Biology. So we're doing a little bit of kind of looking at the empirical evidence and what we've found to help establish our argument. And then we'll go a little bit further with the 3 monads at the end and see their significance. Okay, so on the left, many of you are familiar with Fibonacci numbers, which begin with 0 and 1, and each new number is the sum of the previous 2. So 0 plus 1 is 1, 1 plus 1, 2, 1 plus 2, 3, 2 plus 3, 5. So you see a child can actually create this series. Another series that's even more pristine, closer to perfection, because it's closer to the forms. I'll try to explain a little bit of that, is the Lucas numbers. Now notice here we begin with nothing and something comes out and then reflects itself, much like we see in Judaism in the Kabbalah with the Ancient of Days reflecting itself in like a mirror. Here we begin with the dyad, and then we move to the monad. From the 2 comes the 1, and you add those, you have 3, and you have 1 plus 3 is 4. Our magical number of theosophy is 7. 3 plus 4 is 7. And we're going to see just how magic it is in a second. Also notice these first 4 numbers are 1, 2, 3, 4. They are the beginning of the quadrivium. They are part of the secret. But notice that the first 2 numbers are inverted. The inversion of 1 and 2 gives you a tetractys that's very esoteric, and I'll just leave it at that. Really have not gone into this before, but I'm just telling you, this then generates a series where each pair of numbers is an approximation to the golden ratio. We're going to be looking particularly over here at 5, 8, and 13 because of the relationship of Earth and Venus, but also of the microtubules. We'll look at that later. If you counted the spirals in here in both directions, you'd find that there are 34 going counterclockwise and 21 clockwise. Okay, Fibonacci numbers. The Fibonacci ratios asymptotically, when you take any two of the adjacent numbers, you get a ratio, and they go above and below the golden ratio, but reach it in its limit. They're all tending towards it. This is kind of the old Aristotelian teleology, where the divine is pulling everything towards it. This is the resonant kind of feature of nature. And notice that if we take the ones, 1 divided by 1, of course, is 1, and 2 divided by 1 is 2. So within the range of 1 to 2, then it happens very quickly. 3 divided by 2 is 1.5, not far from 1.618. 5 divided by 3, 1.66666666 on to 1 2/3. Ark of the Covenant, 2 1/2 cubits by 1 1/2 and 1 1/2 cubits. So the 2 1/2 is the 5, and the 1 1/2 is the 3. Many of the ancients, architects would use Fibonacci numbers in place of pure golden ratios because, sorry, I just lost my camera up there. I hope that's okay. And also artists, for example, Salvador Dali, on his canvas, is the structure or size of the canvas for The Last Supper is 5 by 3, because it pulls you into the golden ratios immediately, nature's resonance. 8 divided by 5 is 1.6, a little bit less, and then the 13 divided by 8, 1.625, 625 on to infinity, etc. So you see what happens. But furthermore, Fibonacci numbers, well, let me back up here again. The golden numbers, the greater and the lesser, at the outset, they're not numbers. We call them numbers. They're pre-numbers. They're ontological entities. When the golden cut happens at the very beginning, this is not a mathematical calculation. It's an ontological act. It's ontology. And so the greater and the lesser are components that build up the integers. So let's go through, because it's important you try to understand this. So the greater to any number to the 0 power is 1. So the greater to the 0 minus the lesser to the 0 is 1 minus 1 is 0. Greater minus lesser, 1.618 minus 0.618, that's 1. It's exactly 1. These incommensurable numbers are what give rise to integers in nature. 2 turns out to be the greater plus the lesser. Just take a look. 1.618 plus the lesser squared, which was the 0.381. Notice if you add 6 to 3, you get 9. 1 plus 8, 9. 8 plus 1, 9. 0 plus 9, 9. 9, 9, 9, 9, 9. You're going to see this in a second. I'll show it to you. All of these numbers are functions of the greater and the lesser combined in different relationships. Now you might say, but wait a minute, the number 2 is the exponent here. All that is what we call iteration. It's the greater times the greater. It's this ontological entity multiplied times itself, or 3 times or 4 times, etc. So again, we see it in the pine cone. So if we look at the pine cone at the bottom here, you'll find we've already counted them going around the one direction will be 13. If we count these going around the other direction, there'll be 8. Sometimes they'll be Lucas, but very seldom. But it's because they're closer to perfection, as I'll show you in a second. You take a pineapple. Here you have the more vertical is going to be the higher number. So there's 13 going around, then 8, and then 5. So you get 3 Fibonacci numbers. 8 becomes the approximate geometric mean. So whole numbers in the Fibonacci, they're not perfect but they're basically what's going on. So for example, if you multiplied 13 times 5, you'd get 65. But 8 is the geometric mean or the square root of 64. So you'd have to subtract 1. If on the other hand, you had done 3, 5, 8, 3 times 8 is 24, but 5 is the square root of 25. So you'd have to add 1. So all the way to infinity, you're adding or subtracting 1 to get back into exact geometric means. You also, of course, again, have the sunflower and the Romanesco, incredible, but with also showing the fractals as well. So in a beautiful book, Symmetry in Plants by Jean and Barabe, we find, they say, daisies and sunflowers are the emblems of phyllotaxis. All the problems are summarized therein. The presence of particular numbers, Fibonacci numbers, the genetic angle of 137.5 degrees, the golden number, which is our greater and lesser, and forms logarithmic spirals, for example, in the capituli and the shoot apices, demands an explanation. And it has served as a spur to the human intellect. It is in phyllotaxis that symmetry in plants is most striking and puzzling, but it is also the key to how nature works, or certainly one of the keys. Now we find that there's many more than this, but at one point they would say there are 250,000 species of higher plants. I probably found another 250,000 in the rainforest, some of them which look like they're more insect, plant, animal combination. But there's only 3 basic types of leaf arrangement. Now that doesn't mean you don't get these types intermingling. That does happen. But the 3 basic types, you have the distichous at 180 degrees going back and forth. You see like corn where they go side to side. If a 360-degree circle, you take it 180 out to the sides. Then you have what's called whorled. And if you look at the top of the plant, you'll find a cross like this. That's how they form. So it's kind of fourfold at right angles. Then you have spiral phyllotaxis, in which the leaves spiral. Actually, here's a good example over here after Schneider's drawing, where you see how these things will form. The buds, this is at that 137.5 degree angle. By the way, it doesn't mean that at each turn, you're going to find the next bud. Sometimes they'll skip. So John Martineau, when I was doing the Golden Section book there at Glastonbury, he went out to the Tor and examined a pussy willow. And what he found was that after 5 turns, you don't get 8 buds, you get 13. You get the golden ratio squared. Again, it's like a pulse, a rhythm of nature. This is how nature works. And underlying the diversity is an unexpected and startling degree of order, according to Brian Goodwin, who is the Rupert Sheldrake of sacred geometry. Well, actually of evolution. I mean, he's everything Sheldrake is, plus he understands the golden ratio, root 2, root 3, etc. And here's what he found. 4 out of 5 of all species of higher plants have spiral phyllotaxis. Rotation angle is limited to only a few angles. The most common is 137.5 degrees. That's what you get if you take 360 and golden cut it, you get 222.5 and 137.5. And so if you have a bud here, there'll be a tendency for the next bud to come up here, then it'll be another 137.5, 137.5, and that's how it rotates around. We also see this with the phalanges of the hand. In fact, the human body is a harmonics of golden ratios, probably Fibonacci approximations. You know, nature tends to use whole numbers, the integers. So for example, if you're going to count the number of leaves on a tree, you're not going to get a golden ratio number of leaves. You're going to get a whole number. However, the relationships are so incredible. So if you take the distal phalange and compare it to the medial phalange, it'll be in golden ratio. Here we have 1 is to little baby phi, which is also the same as 1/5. That's the other symbol we use for the lowercase phi symbol, we call it phi, for the small lesser. The greater here is to 1 as 1 is to the lesser. Greater squared is to the greater as the greater is to the lesser, etc. The whole thing fractalizes, and the whole human body then becomes this kind of symphony of golden ratios. Here's a golden calipers with threefold. Here I'm using just a simple calipers, where on the other end, you flip it over and it'll take you to the next, would take you to this phalange. Okay, so Lucas numbers, beginning with 2, then you have 1, 3, 4, 7, 11, 18. We want to remember these numbers right here, 3, 4, 7, 11, and 18 for a good reason. So here you begin with, if we're making fractions, obviously we take this number, divide by the previous number, we get 1/2. So we begin with 1/2, and then 3 divided by 1. So between 1/2 and 3 is the range. And then very quickly, 4 divided by 3. Yes, it's not the golden ratio, but it is a Lucas approximation. And I'll show you in a moment why Lucas is so important. And that is also the musical fourth. Then we have 7 divided by 4 is 1.75. 11 divided by 7 is 1.57, a little bit less. Then we have 18 divided by 11 is 1.63, 63, on to infinity, again, a little bit above, but they asymptotically, they're moving towards the golden ratio. They're being pulled towards the golden ratio to infinity. If, by the way, we took the smaller number and divided by the larger, we would then be approaching 0.6180339, be the exact same thing without the number 1 here. So here's Lucas numbers, and here's why they are so very important. So again, obviously greater to the 0 power and lesser to the 0 is 1 plus 1 is 2. So you get your first one. But notice now we're going to alternately add, subtract, and notice the exponents here. 1, 2, 3, 4, 5, 6, 7. Same thing on the other side. When we take the and add, well, when we take the greater to the first power, mainly the greater, 1.618, minus the lesser to the first, we already saw that, you get exactly 1. You take the greater squared and you add the lesser squared, you get exactly, not an approximation, this is how the integers form. This is the caduceus. The greater and the lesser are the two serpents. They're also Ida and Pingla, Sushumna in the center. They are feeding into the integers, alternately adding the greater and lesser together and subtracting. So for number 4, we take the greater cubed, which is 4.236, etc. The lesser cubed is 0.236. Those numbers are identical. You slice off the lesser and you get exactly the number 4. Now here's our magical number. You take the greater to the 4th power, 6.854, etc., and you add the lesser to the 4th power, 0.145. 8 plus 1 is 9, 5 plus 4 is 9, 4 plus 5 is 9, etc. 1 plus 8 is 9, 0 plus 9 is all the way to infinity. We'll see that in a moment. And so you have the alternation of the powers of the golden, this is the golden series of the greater golden series, and this would be the lesser golden series. So it was Leopold Kronecker who maintained that God created the integers, all else is the work of man. But how did the source create the integers? And that's what we're getting at right here. Every single integer is a combination of the greater and the lesser of what we're going to call beauty and truth. So here we have the greater to the fourth, 6.854, etc. And we have the lesser to the fourth, which is 1 over the greater to the fourth, 1 over 5. There are different ways to symbolize this one. We could have used a little symbol phi to the fourth power, and that's 0.1458. Now notice what happens. We're going to add them together. Notice how each of these become 9, 9, 9. It's 6.999999, all the way ad infinitum. And again, ask any good mathematician, this is exactly the number 7. That's how nature works, combining the greater and the lesser of the golden ratio. Now we want to look at the measurements of the human skull because it's very, very interesting. We're going to look at the nasio-iliac arc, the nasio from the nasal here all the way back to the ilion, which is compared to the entire line length here. And then it's bregma, where the sutures, the coronal and the sagittal sutures meet right at this spot. And this is how the brain architecture works. And there's an argument that we'll see in a moment that the architecture evolves towards the maximal, most efficient way for the frontal cortex, the frontal lobe, to work with this back area. And so if we take the entire nason ilion and compare it, and I'm highlighting and they should flash for you, the bregma to the ilion, we have 18:11 or 1.63. And we remember that 18 was simply the greater to the 6 plus the lesser to the 6. And the 11 was the greater to the 5th minus the lesser to the 5th. Again, in sequence now, adjacent Lucas numbers. Then if we compare the bregma to the, I'm sorry, bregma ilion to the nason bregma, we have 11:7, which is approximately 1.57. And what Tamargo and Pindrick did is they compared various mammals, and they found that the human skull structure is approximating at the bregma break to this relationship. You see on the top here, that's the nason ilion arc relative to the bregma ilion arc, and then below is the bregma ilion relative to the nason bregma arc. Now, here's what's interesting. We find that the tiger and the lion, even more so than the monkey, the dog, you see the sequence here. You have the rabbit, the blue monkey, domestic dog, rhesus monkey. The tiger and the lion are very close, and they didn't realize it, but I did the calculations. And so here's what we're going to get. The biometric measurements in the lion and tiger skulls are ratios of adjacent Lucas numbers. So the nason iliac arc is as if it's 7, and the bregma ilion arc is 4, which 7:4, 1.75, a Lucas approximation. But remember what these Lucas numbers are. Those pure numbers themselves are immediately simply like 7 is the greater to the 4th plus the lesser to the 4th, as you saw. And 4 is simply the greater to the 3rd minus the lesser to the 3rd. Okay. So then when we compare the bregma ilion to the nason bregma, it is 4:3, 1.33. But again, it's extremely interesting because we've had, with humans, it's 18:11, and 11:7, and then we get 7:4, and 4:3. Now, this should not be surprising for any of you who, like me, has somewhat of a shamanic background or include that as part of your path, because identification with the big cat is not uncommon. Why? Because they're the top of the food chain. All the consciousness of all of the plants, insects, animals are in the big cat. For me, jaguar in the jungle. And through communication and identification, you learn everything about what the animal kingdom knows about this despicable human kingdom that you and I are a part of. Anyway, enough said there. So we see this everywhere, that the nucleotide frequencies in the human genome and Fibonacci numbers, for example, in this article by Yamagishi and Shimbakuro, or in investigation of Fibonacci-like sequences in biology and math, or Pedikov, one of the authors of my next, who's contributing to my next book, Divine Proportion, the Mathematical Perfection of the Universe, metaphysical aspects of matrix analysis of the genetic code in the golden section, etc. It keeps going. And Perez discovered the golden ratio in the human genome. He discovered that codon populations in single-stranded whole human genome DNA are fractal and fine-tuned by the golden ratio, and related to Fibonacci and Lucas numbers. And he found two binary code attractors. The top state matches the lesser, okay, our lesser golden ratio of 0.618, and the two, and the lesser, I'm sorry, the lower, the bottom state is 1/2 of the lesser. So again, it's like 2 to 1. These two states create a self-organizing bistable binary code that are in perfect octave of one another. The genomes of Homo sapiens and Neanderthals exhibit Fibonacci and Lucas resonance. See Jean-Claude Perez. In 2009, Perez found widespread occurrence of the golden ratio and the Fibonacci series throughout 20 various species. The codon populations of these various species, got to move this, including simple cells and viruses, showed the 3 parameters are 1, 2, and big phi, the golden ratio, and they define these populations to a precision of 99% and often 99.999%. And of course, here's the corona down here. Here's HIV, which is actually icosahedral. Before you would truncate this thing, this is the truncated icosahedron that I was talking about before. I'm sorry, this is the icosahedron. So you see, if that's 1, that's the golden ratio along that side. In fact, these are interpenetrating golden rectangles, they're called, and you see that in the HIV virus. That also tells you something about nature. That nature, it doesn't mean that simply because you have a golden ratio, it's good. It's also the difficult things have these qualities as well, or take them on and make them almost impossible to get rid of. Pedikov confirmed Perez's supercode of DNA and then went on to discover a law of golden genome matrices underlying the genetic code. Now get this, which is based upon 2 values only, the greater phi and the lesser phi, our greater and our lesser. And you see this in metaphysical aspects of the matrix analysis of genetic code in golden section. Also see it in his book that he did with Matthew He, Mathematics of Bioinformatics. Pedikov is also contributing to my next book. A lot of Pedikov is also in the new book, Grand Unification. Systolic and diastolic blood pressure follows the golden ratio. So just take the ideal 120/80, that's 3:2. 40 goes into 120 3 times, into 80 twice. It's a Fibonacci approximation of the golden ratio. The greater golden ratio is present in the human heartbeat's cardiac cycle. Ideal human biomechanics and gait are governed by the golden ratio, leading to the view that the idea that humans may have evolved into the actual anthropometric proportions for favoring walking, having a golden ratio based harmony. And because you're recording this, you can look at this more clearly later on. MIT physicists, led by Pablo Herrero Herrero, discovered that two sheets of graphene twisted by about, notice this language, about 1.1 degrees allow electrons to become easily entangled and superconductive. When they get entangled, that's when you get non-locality. We, the authors of Grand Unification, authors of my new book with me, predict they will eventually discover this angle is precisely the lesser golden ratio to the 11th power, of course, multiplied times 360 degrees, or it's going to be 1.118023205 degrees. Gredzelsky proposed the role of the golden ratio in entropy as the governing proportion underlying thermodynamic equilibrium in self-organizing system. I should have Pam give us the correct pronunciation of that name. Resonance. It's all about resonance. H.P. Blavatsky, our co-founder of Theosophy, author of Secret Doctrine, wrote, "Atoms are called vibrations in occultism. We now know that the brain waves of musicians fall into synchronization, according to researchers at the Planck Institute and the University of Salzburg." Former dancer Judith Snow, a theosophist, once told me that her instructor would get very upset because many of the dancers, female dancers, suddenly went absent, essentially at the same time because of their menstrual cycles. Of course, it's lunar related. We observe synchronous attunements in the flight of a flock of birds, the sudden simultaneous movements of a school of fish or swarm of bees. In physics, we find it in superconductivity and superfluidity at or near the absolute, well, near absolute zero, where everything moves in lockstep coherence, unrestricted by the normal constraints of gravity and other barriers. The silent pulse. In 1665, the Dutchman Christian Huygens gave one of the first explanations of what scientists later referred to as entrainment, or the mutual phase locking of two oscillators. Huygens observed that two pendulum clocks left hanging on a wall beside each other tended to fall into a synchronous rhythmic swing together. He maintained that there was a kind of sympathy established between them in which they sought to keep the same time, attuned with one another in a synchronous pulse. This universal phenomenon is now known to occur whenever two or more oscillators in the same field are pulsing at nearly the same time. They tend to lock in so that they're pulsing at exactly the same time. So I'm going to show us the synchronization of 32 metronomes. And I think you'll get the sound in this, hopefully. And of course, I had to speed it up. And I do want you to notice all these metronomes are in a single board. They're pulsing together. So the resonance can occur. This is the bottom of a tin can. I've showed this in previous presentations, but it's very important. Some of the first photographs of the bottom of a tin can, first photographs of holograms of a bottom of a tin can resonating at different frequencies, showing you how sound is transformed into shape. And of course, here, this little child with these Archimedian solids and other more complex solids, they really are more than just big toys because there's resonance. And of course, here we see the 13 Archimedean solids and the 5 regular solids. How do they differ? The Archimedean solids have more than one face, whereas the regular solids, all of the dodecahedron are pentagons. all of the tetrahedron, for example, and icosahedron and icosahedron here and octahedron are equilateral triangles. And then, of course, all of the cubes are squares, but then you get a mix with the 13 Archimedean solids. Recognize 13 as a Fibonacci number, and of course, the 5 as a Fibonacci number. Did I say? Yeah, both are Fibonacci. Okay, I wanted to take a little time to explain this more fully, but I think time-wise, I may have to kind of get galloping here. But just notice the piano keyboard down below, and this is really important for the overtone series and what's called Greek gematria. The Greeks understood this perfectly. They learned from the Egyptians, and their language itself, alpha, beta, gamma, delta, 1, 2, 3, 4. The letters are numbers, the same with Arabic, the same with Hebrew, the same with Sanskrit. And notice 1, 2, 3 to 10 here are the keyboards. You see the notes here, their vibrational frequencies. You see which note is involved, the exact value. And then you have the gematria value of Hermes, the lyre, the god Hermes. When you combine, the god is also very close to 353. And you can, what they did is they would take the names, and you could have one above or one below, and you could go the equivalent of 3 decimal places, but that was it. And you'll notice that they're all functions of the square root of 2. From the fundamental tone beginning right here, and then doubled right here, so that actually would be an octave, 2, 3, 4, 1/8, 2/8 would be 1/4, 3/8, 4/8 would be 1/2, all the way up to a full square root of 2, then 9/8 of it, 10/8, and you see the names that are involved are the god Apollo, Hermes, or the god Hermes, and Apollo, and the lyre. And out of those, you get the entire thing. Now, something important, think also in terms of who those gods are. Apollo and Hermes, brothers who exchange gifts, so to speak. Hermes, who has invented the lyre, gives it to Apollo. Here you get the harmony, the music, the resonance, and Apollo gives to Hermes the caduceus, probably the most sacred, along with the pentagram, the most sacred symbol that there is in existence. Here we are in Peru, up in the mountains with the Quechua-speaking Caro. They're the remnants of the Incas, and we're using whistling vessels that they have in the museums, but they had forgotten about how to use them. Now, what's interesting in these non-ordinary states of consciousness or in meditation, one can enter into synesthesia, where the senses cross over and we begin to see sound, hear colors, all the senses can cross over. Here, Tito La Rosa is playing a charango with the condor feather. And it's also important when one is beginning to open the third eye and you begin to see sound in the third eye, but you also, all the senses cross over. The most fascinating thing that happened to me once was that I had the experience of a jaguar, and I realized they can smell your heart beating at a distance. And so rainforest resonance with the plant and animal teachers. It's not just the animals, it's the plants as well. And it's a kind of harmonics throughout the entire world. And it's learning how to go into resonance with one another. And certainly in this Aquarian age with group activities, we're going into resonance, consciousness. The first Penrose anomaly. Why do Fibonacci numbers appear in microtubules? Because they create golden ratios in their relationships. In 2019, Hameroff indicated, and that was at a conference in Interlaken, Science of Consciousness, that EEG waves are which are appear to be the result of microtubule oscillations. They're interference beats of the quantum vibrations in microtubules. That's been a big mystery about where these, the EEG, the brain waves are actually coming out of. And this includes the gamma synchrony, which now is considered the best neural correlate of consciousness itself. In 2019, Hameroff observed that his and Penrose's theory, orchestrated objective reduction, indicate that anesthetics dampen microtubule vibrations, and psychedelics, or what I call entheogens, promote quantum vibrations in microtubules. Tangled, now here's the big problem that we all should be taking a look at. Tangled or mucated tau protein molecules, which when normal, so let's take a look. Here's a neuron. Here are the microtubules in the neuron. Here's a microtubule. Here are the tau molecules. They stabilize the structure of the microtubule. However, when they get entangled, they result in microtubule disintegration, which we have over here. Guess what? Leading to dementia, Alzheimer's disease, destabilizing consciousness, and apparently this is maybe the source of cancer as well, because these microtubules are not just in neurons, they're in all cells in the body, and they're also in mammals, and they're in plants. I should make a note here of this bottom remark by Tuzinski. Mitochondria are photon entities, and microtubules may be like antennas, maybe receivers. Clathrons closely associated with microtubules are involved in synaptic neurotransmitter release. And as I said, there are these truncated icosahedra. Here's kind of an image of one, but here's the geometric structure. So if the edge of this soccer ball is 1, you go directly across, or football, go directly across to the other side. That's exactly 3 greater golden ratios, exactly. And that's what's in resonance there in the synaptic cleft. Let's go down to Croto here. He won with some others the 1999 Nobel Prize in Chemistry for carbon-60, which is a truncated icosahedron. Here at the bottom, we're in Delft at the Symmetry Festival, and here's the truncated icosahedron. Here again, carbon-60 has this golden resonance. Physics of consciousness. Okay, now we gotta, I think, start wrapping up a little bit. The chaos border finds structure constant and quark masses as established by El-Nashi are functions of the golden ratio. The CAM theorem, or which is the chaos border, the border between chaos and order, is ruled by the golden ratio. And since the golden mean is the most irrational number, the corresponding orbit is the most stable orbit, thus allowing one to observe a particle. The inverse Sommerfeld electromagnetic fine structure coupling constant is a function of the golden ratio. It's 20 times the greater to the 4th power, or 137.082, etc. In fact, in 2010, the golden ratio was found in the phase transitions of quantum mechanics. By the way, that was a lab at Bristol University, where we hold the summer school sometimes, and also in Germany and one other location. All quarks are functions of the golden ratios. All you have to do is look here of the masses of the up, down, strange, charm, beauty, and truth. And you see the symbol here. They're all functions of the golden ratio. They make up the subatomic particles, which make up cells, organs, etc. We do have a couple of, well, several videos that one can tune into. One is the golden universe is a golden supercomputer. That's El-Nashi and myself. And then we also did this series, three-part series about, I think there are about 24 or 25 videos, El-Nashi and Olsen in conversation, especially series 3, part 8, take a look at. Those are free, look on the internet. The second Penrose anomaly, quantum reduction must be a non-local process. Again, it is the entanglement that Lucian Hardy discovered that allows this non-locality to occur. And he found that non-locality occurs at the golden ratio, the lesser to the fifth power, which is equal to 0.090169444, but he rounded it off to 0.09 or 9%. For that reason, El-Nashi, Penrose, and others who would have realized what was going on didn't recognize it immediately. But it is exactly the golden ratio to the fifth power, the lesser. El-Nashi found it remarkably exactly twice as large as the ordinary energy density of the universe, which is 4.5%. In other words, the universe we can see and interact with that is not dark is only 4.5%. And that's how you calculate it. It's the golden ratio to the fifth power divided by 2. It's what Hardy found, but 1/2. 95.5% of the universe is dark matter and dark energy. In fact, El-Nashi found that dark matter is 4 times phi to the 6th, and pure dark energy is 5 times phi to the 4th power, or you see the percentages over here. Now, we're getting down to the nitty-gritty. In the double slit experiment, where you have, whether it's a single slit or double slit, whether you get a wave or get a particle, whether you collapse the wave through observation, or again, it's coming from the future in some really odd retrocausative way. What's interesting is the wave multiplied times, now get this, the greater big phi golden ratio, multiply it, hammer it with consciousness or the future, you get the particle. So the wave multiplied times the golden ratio is what gives you a particle. Golden Fibonacci anyons, which are neither fermions nor bosons, in fact, they're two-dimensional, provide the simplest model for universal quantum computation by particle exchange or braiding alone. Again, you'll be able to look at this more carefully, hopefully in the YouTube. I guess actually you're not going to have the video, so it's going to be just as fast as I have it here. I guess you can pause it. According to Herman Otto, Fibonacci anyons as qubits may be the ultimate approach to quantum computation because they naturally simulate processes which determine the speed and storage capacity of the human mind or of the brain, cosmos. So John Martineau and others have noticed that if you connect the Earth to Venus over an 8-year period, you'll get a rosette. You'll get this you have the sun in the middle, you get this rosette, a 5-fold rosette. 8:5 golden ratio, but it's 13 years on Venus. So just like with microtubules, 13, 8, and 5, or pine cones, in the solar system, we're seeing the same thing. As above, so below, and as below, so above. And it's the golden ratio, which is the geometric mean, which ties together the above of Hermes and the below of Hermes. You need the third factor, as Plato pointed out. The relative mean orbits and mean diameters of Earth and Mercury, well, if you take the orbit of the Earth, if it's this, the mean orbit, the average, and you take the average or mean orbit of Mercury, it's the greater golden ratio, phi squared is to 1. The orbits of Neptune and Pluto are in 3:2 Fibonacci resonance, which is a musical fifth. Now, one of the solar systems that they are looking at very carefully for life, and for good reason, because 4 of the planets are Earth-sized and have the possibility of water, but even as interesting is in TRAPPIST-1, we have 6 planets which have orbital frequencies of 8, 5, 3, 2, the musical fourth, 4/3, and 1. We have Fibonacci numbers and intersperse the musical fourth with these Lucas numbers involved, interestingly. The adjacent orbits of all 6 planets of Kepler-11 are virtually in 3:2 Fibonacci resonance, again, the musical fifth. And you begin with the first inner planet moving out. That means for every 3 orbits each planet makes, the next one out completes 2 orbits. All the planets are locked in rhythmic harmony like a waltz in a cosmic ballroom. The recent reassessment, of the Planck satellite now makes it more probable that the universe has curvature rather than being flat. Now, I realize there are many arguments about this. It's not a done deal. However, the anomalies, the puzzles of the second and third harmonics of the cosmic background radiation being weaker than expected, abductively, not deductively or inductively, abductively, creatively, hypothesis formation, eureka, suggest a dodecahedral universe. See the article in Nature and Luminet himself. Concluding remarks. Together, this family of anomalous facts abductively lead towards an inevitable inference to the best explanation of a golden superstructure based upon the one and the indefinite dyad, providing a proportional golden mean number system that is infused into what Bohm would call the implicate order of nature and the cosmos as its very substructure. And then it comes out as its explicate order when we see the Fibonacci numbers, etc. in nature. Life, hylozoism, and consciousness, panpsychism, and we think cosmopsychism. It's not just everything is aware, but the cosmopsychism is involved. They pour in from the very beginning in the holo movement, writing these golden numbers from the superstructure that appears with the initial ontological act, the big cut, the big bang, the primordial scission. This points to a grand unification of the sciences, arts, and consciousness through a golden mean number system. As Bohm would suggest, each part has the entire universe enfolded into it, with all the infinite potential and possibility implicit within that can be unfolded along the way. Mystery of the three monads. Okay, now we know we got a pretty good handle on, and I've reversed these. I put the lesser on the left so that we kind of increase in size. The earlier image I had reversed. Doesn't matter. So the lesser, little baby phi, 0.618, is the truth monad. When you read Plato and the Philebus, and I'm not going to get into this in detail, but he makes it very clear that you have truth and beauty, and if the greater monad is big phi, 1.618, that's beauty. The mystery surrounds what is the symmetry monad, and it really involves one, but why does he call it the symmetry monad? And as we noticed when we did the fractalization, the original source, which remained unity or one, is not identical to the one that plays a role between the lesser and the greater. Yes, it's the number one, but somehow the source itself, Brahman, isn't quite the same as Atman, but we're going to see that in a second. So there are three means, and for the mathematicians here, if you take two numbers, any numbers, A and B, and you add them together and divide by 2, you get the arithmetic mean. So let's say you take 4 and add 8, you get 12. And you divide by 2, so the arithmetic mean would be 6. Geometric mean is the square root of the two numbers. 2, let's say A is 2, B is 8, 2 times 8 is 16, square root is 4. So 4 would be the geometric mean of those two numbers. And then the harmonic mean gets a little more, but we got to keep moving here. I was about to say it's a little more involved, but so Lance Harding uncovered the following significant relationship in the golden series, where the AM here is the arithmetic mean, GM, geometric mean, and HM in red is the harmonic mean. And right away, you're going to see here the greater 1 and the lesser, this is the same as 1 over the big phi, this would be phi squared. This would be 2.618, for example. If you go this direction, you get smaller and smaller. It's Alice in Wonderland, through the looking glass. Eat me. Go smaller this way, go larger this way. But it's all golden ratios. Now, he did this when he was looking at Le Corbusier's modular. And he realized what he was doing, Corbusier, using the golden ratio. And of course, this is Lance getting his PhD from the Prince of Wales. He really is the expert now on the canons of human proportion. He also did this beautiful Vitruvian Man. Since John Michel has passed, Lance is kind of the king of, or the leader of ancient canons of human proportion. Now, while working with John Martineau on his new book, Adam Tetlow, his new book is The Diagram, Harmonic Geometry, another wooden book, as my golden section is. Adam Tetlow made the following observation, and he contacted me and others. Schneider had never seen it before. I had seen it before. Not exactly this, but I realized in the earlier slide, I showed Adam and John that really Lance had been figuring this out before. But what Adam did by showing us this, now notice here, he's got the geometric mean between the lesser and the lesser cube. So the lesser squared plays that role here. Here he's got big phi as the arithmetic mean between between phi squared and little baby phi, and the harmonic mean he has as phi between 1, and then we jump over to the greater to the third power. Now, what he really was doing here is he reminded us of the internal structure of the harmonic, geometric, and arithmetic means on the golden series. So I'm going to show it to you here, that it can slide back and forth each of these relationships and they retain their structure. So the geometric mean is consistent throughout. The middle term is always going to be the geometric mean between the other two. So here we have the same thing going on with the harmonic mean. That structure remains the same. And here with the arithmetic mean, you can just travel up and down the golden series. This is the backbone of the world, actually. Now, what this did is it allowed me to realize, oh my God, here's what's going on. The real center of this, 1 and the indefinite dyad, is what's at work. However, this allowed me to uncover the underlying mystery, the 1 as the symmetry monad, because what's happening is the 1, we begin with this business right here. The 1 is acting as the monad of symmetry, which is allowing this to happen. Thus, the 3 monads of beauty, truth, and actually this is, we would call this the good or the 1, but this is the symmetry monad. And what it's doing is it's linking, well, let me back up. So thus, I'll just read it out. Thus, the 3 monads, truth, beauty, and symmetry, are enfolded as the golden mean number system into the substructure of all existence. And of course, yes, as above, so below, and as below, so above. But it's doing this when the 1, the symmetry monad here in the center, simultaneously acts as the arithmetic, geometric, and harmonic means. So you can see what's happening here. Let's just take the arithmetic mean. You see that 1 is the arithmetic mean between the greater big phi and the lesser phi squared. And it's the harmonic mean between the lesser and the greater squared. This is the paradigm of harmonics that is thrust into the structure of the world. So the mystery of the 3 monads, the symmetry monad now in the center, it is unity, yes, but it's playing that role. And when you get to the summit of the cave, you're going to get to the lesser and the greater, and the 1 is going to be there in the distance. But there's a couple, actually 3 different ways, well more. I'm going to show you some other ways that you arrive at it, and the possibilities of samadhi and finding the Atman, because the greater minus the lesser gives you 1. The greater times the lesser is 1. The square root of the greater times the lesser is 1. It is 1, and it is true. It's also -1, which is another mystery that we're not going to address at this point. That'll be a future event. But here's the deal. If you discover the Atman, it becomes a small step of identification with Brahman. Atman is Brahman. Plato would call it the good. This is the source. So the big question at the beginning, how does the one become many? Okay, we figure out the pattern. It becomes Ariadne's thread. The thread back up out of the labyrinth, back to the Father in heaven, or whatever you want to call it, back to Brahman, the potentiality of illumination. Now, one example of this is Edgar Mitchell, who went into samadhi on his return from the moon. I'm not going to go into all the details because we need to end this, but he did enter into samadhi on the way back. He also conducted a successful, statistically significant psi experiment during that event. And he also was very interested in my work with him. We became very good friends, was the abductive reasoning, which is behind much of what we're doing here. But here's the statement that he made in The Way of the Explorer regarding his experience. I experienced a grand epiphany accompanied by exhilaration, an overwhelming sense of universal connectedness, an ecstasy of unity. And there was the sense that our presence and the existence of the universe itself was not accidental, but there was an intelligent process at work. I perceived the universe as in some way conscious. From that moment on, my life was irrevocably altered. This precious stone, the golden mean number system, is rooted in the golden section, or as the ancient Egyptians named it, the primordial scission, emerging from what Gordon Plummer, another one of our theosophists, called the great breath. It is also known as the principle of equilibrium. In fact, in chronological Mahatma letter number 90, KH states, we recognize but one law in the universe, the law of harmony, of perfect equilibrium. Now let's make it clear that with equilibrium also comes disequilibrium. So there is order and there is chaos, but this is nevertheless the key to the whole thing. And the great alchemist and Egyptologist Schwaller de Lubitsch, after studying the Temple of Luxor for 15 years, concluded the golden section is not a product of mathematical imagination, but the natural principle of the laws of equilibrium. Yes, we can calculate it with the square root of 5 plus 1 divided by 2, or square root of 5 minus 1 divided by 2. Yeah, we can do it mathematically, but initially, these are ontological events. These are objects of the universe that go to making it up, and it's the one and the indefinite dyad. This is the ultimate trinity that's at work throughout. And ultimately, our goal is homo luminosity, not homo sapien, the human being in the enlightened state. And because of the golden ratio throughout nature and our bodies and everything, we're hardwired for transformation. And this is none other than transmutation. The whole thing is alchemical from beginning to end. We are like stem cells with a purpose. Here are 2 of my co-authors, Mohammed El-Nashi in the center, Zhouan He. We're in China for a mini symposium on dark energy back in 2012 that I had chaired. And this is the new book. And what this is leading to, because the book is so fascinating for El-Nashi, he thinks we knocked it out of the park. In fact, he said the book is the equivalent of Newton's Principia back in the time of Newton's Principia, once people get access to it, that I've been invited to Egypt to meet the president. Well, if I'm going to Egypt, I'm going for an extended period of time because I'm going back to investigate the pyramids and the temples up Karnak and Luxor, but especially the Giza Plateau, and we're bringing the book down to Alexandria. So the most importantly, I'm going to be working on the Great Pyramid and looking into what they know and has not been leaked out regarding that hidden chamber they've now found above the Grand Gallery. But there's much more. There's a causeway to Khafra's pyramid, where the underground temples are. So the whole purpose is for me to find out as much as I possibly can about Egypt. Thank you very much for this opportunity. I do have a couple websites. They're in their infancy, goldensection.expert and mysteriesoftheamazon.com. Goldensection.expert actually has the references, links to the references for the new book. And this is my email, olsen@cf.edu. I'm happy to answer any questions by email as well. So thank you. I appreciate it. Thank you.